Okay, here's part 2 of your review. Another rational equation. Actually, you've got a couple of these that are rational equations, and then we have some more where we're either simplifying or determining where it's undefined, or even one where we look at a graph before we start sequences and such. Alright, problem number 8. This one's got a little bite to it because there are 3 terms. It is not a proportion, so you can't just cross multiply here. You need to find the least common denominator and multiply both sides by the least common denominator. Well, to find the least common denominator, every rational expression, and I mean technically you could think of this as over 1 if you wanted to, every rational expression, the denominator should be in factored form. That doesn't factor, of course that's not going to factor. X squared minus 9 is a difference of squares. This is x minus 3 times x plus 3. So I am going to multiply by the least common denominator, and since this factor is in this is my least common denominator. I'm going to multiply both sides, every term on both sides, by this common denominator. So I'm going to write it in green here to really emphasize x minus 3 times x plus 3. This is going to be times this. So that's times, oh, come on, pen. Times 30, and I'm going to write this in factored form, x minus 3, x plus 3. Hopefully I'm not writing too small. Plus, and then I'm distributing, so I'm just going to go ahead and multiply it times the 1. So this is x minus 3, x plus 3 times 1 equals, and then on the right side I multiply it by x minus 3, x plus 3. And that is times 5 all over x minus 3. So here when I multiply, everything cancels top and bottom like that except for the 30. Plus, here nothing cancels out because you're just multiplying it by 1. X minus 3 times x plus 3 times 1. Well, anything times 1, it's just that anything. So I'll actually multiply those together because I know it equals x squared minus 9. So this is x squared minus 9 equals, now over here, the x minus 3's cancel, but I'll have 5 times x plus 3. And you can see right away, you have a quadratic. So to get a quadratic equation solved, you must have it in standard form. So I have to simplify both sides and get everything on one side so that it's set equal to 0. I can combine the 30 and the minus 9, I get x squared plus 21. And then over here I have to get rid of the parentheses, I get 5x plus 15. Now I'm going to kind of double up the steps here. I am going to subtract the 5x from both sides, and I'm going to subtract the 15 from both sides, kind of all in one step here because I didn't give myself very much room. So I have x squared, and then I have the minus 5x, those are not like terms. And then I do have like terms, I have a plus 21 and a minus 15, that's a plus 6. And then over here, these all cancel and it gives me 0, which is standard form. So you either have to factor it or you have to use the quadratic formula, and this factors. This is x minus 2 times x minus 3. So that means x minus 2 is equal to 0 or x minus 3 is equal to 0. Remember, when you're solving a quadratic equation, if you can factor it as far as it can go, then you set each factor that contains a variable equal to 0. Because this times this is 0 only if the first one is 0 or the second one is 0. Now I have 2 simple equations to solve. I have x equals 2. And over here I'm going to add 3 to both sides, and I have x equals 3. Now there's a problem. X equals 3, if you go back to the original problem and plug 3 in, you're going to get 0 in both of the denominators. This is extraneous. You must toss it out. However, 2 is not going to make any of the denominators equal to 0. That's a legitimate answer. So whether they want it written as x equals 2 or they want a solution set, okay, it'll be based on the choices for multiple choice. Don't forget, when you're working a multiple choice test, look at the answers, not so much to study them as much as look at the form of the answers so that you can make sure you're matching up. Another equation, find n, and I do have n in both denominators. Now none of these denominators factor because they're all monomials. This is n, this is 2, and this is 6n. I mean, you could factor 6 to 2 times 3, but that's not going to help you much. So your least common denominator, since 2 goes into 6 and n goes into 6n, your least common denominator here is 6n. So I'll get the green pen going again here. I'm going to multiply through by 6n. 6n times this, 6n times this, 6n times this. 6n times 5 over n minus 6n times 1/2 equals 6n times the right side, which is 3 over 6n. Okay, over here, the n's cancel, I get 30. Minus, put the 6n over 1, the 2 cancels with a 2 out of the 6, leaves a 3n over 1, 3n. Equals, over here, put it over 1, and it all cancels except for the 3. Well, that's a simple equation. Subtract 30 from both sides. Careful with your signs. Now notice it's linear, so I don't have to bring everything to one side and set it equal to 0 like I did with this quadratic guy up here. This is linear. We just isolate the variable. And this one looks like it's going to come out to be an integer. It looks like a positive 9. Now before I jump the gun, maybe it's extraneous like this 3 was back here. Well, it's not, because if you plug 9 in here or 9 in here, you are not making either one of those denominators equal to 0. So that's your guy. Always check. Okay, this is called a complex fraction or a complex rational expression is what it's actually called. And it's just a fancy way of saying this big old fraction up here in the numerator divided by this big old fraction down here in the denominator. Now, there are two different methods to simplifying complex fractions. And when you have a fraction over a fraction, the best approach, in my opinion, is to treat it like a division and invert and multiply by the divisor. So what I'm going to do here, invert the divisor and multiply is what I should say. I'm going to take this, I'm going to rewrite it as 3x over x plus 3, and I'm dividing it by x over x squared minus 9, which is 3x over x plus 3 times the reciprocal, which is x squared minus 9 all over x. When you multiply rational expressions, you multiply the numerators, you multiply the denominators, but one thing that students have found very useful is before they do that, to see if it simplifies by some feature of cross-canceling. But you would want to factor every numerator and denominator, and that numerator there, the x squared minus 9, is the only one that factors. I've been seeing x squared minus 9 a lot. There it is. And this is all over x. Now, two things are going to cancel. Not only are the x plus 3 is going to cancel, but this x and this x here, not this one, this is a term in this factor. This x right here is a factor, so I can cancel that with that. So I don't have much left in the denominator. I just have 1 times 1. Up top I have 1, or 3 times 1 times x minus 3 times 1. So that's 3 times x minus 3 all over 1. Now they might have that, and I don't know if I have my copy here. Let's see if I have it anywhere. Yes, I do. And they didn't leave it like that, but they did distribute 3x minus 9. Sometimes they'll leave it in factored form, sometimes they'll multiply it out. Here's your answer. That's what it simplifies down to. Now the bottom two problems here in the middle are both asking for the values of x that make it undefined. I think this is a function. Did I write, forget f of x or something? Was it written f of x equals? No, they didn't. Kind of bad wording there. Anyway, to find out where it's undefined means what makes the denominator 0. So just, don't worry about the numerator. Just take the denominator and set it equal to 0. Solve. Whatever x is, that would be the restriction. That would be the value that would make it undefined, because that's the value that makes the denominator equal to 0. Well, add 8. I get 2x equals 8, divide by 2. I get x equals 4. Now, if they say find the value of x that makes it undefined, that's it. If they said state the restriction, if they said that, then that would be where you would write it like that x cannot equal 4. I believe they just have the numbers, don't they? Let's see. Yeah, they just have the number. Okay. All right, very similar down here. Find the set. Okay, now since it says set, or which set, you're going to probably write it in terms of with braces like this, but for which the fraction is undefined. Well, again, take the denominator, just like I did on the last problem, set it equal to 0. Now this one is quadratic, and it's already in standard form, and it factors as a difference of squares here. So I said x minus 7 equal to 0, or x plus 7 equal to 0. And I get x is equal, add 7 to both sides, subtract 7 from both sides. So the values, the set of values would be 7 or negative 7. Maybe they write it with plus or minus 7. I haven't checked. No, he wrote it out that way. And there's your answer right here for problem 12. All right, now, problem 13, it says, which of the following represents the graph? Now, they give you 4 choices. I'm just writing this one out like I'm doing this without having it set up as multiple choice. And then I'm going to match my answer. Now, here's the trick. Typically, when you have a rational expression, you got to look for things, what makes the denominator 0, because perhaps I'm going to have a vertical asymptote. I have a higher degree in the numerator than I do in the denominator. That makes kind of an improper rational expression. So what I'm going to do is I'm going to factor this, and you can hopefully see it coming because the numerator factors so nicely and the denominator doesn't. Now what would happen here is, you see how the x plus 4s are going to cancel? But remember, x cannot equal negative 4 because it makes the denominator 0. That's its restriction. So what ends up happening is I get y equal to x minus 4, which is a line, except at x equal negative 4, right here, at x equal negative 4, I am going to have a hole in my graph. Now I don't know if I made my scale big enough. I don't think, or my graph big enough. Maybe I need to make these each 2. I'll make each one of these 2. Maybe it'll fit in then. So this is the line that goes through 0, negative 4. That'd be down here. That's its y-intercept. It has slope 1, which would be up 1, right 1. So it's going to go like this, except at x equal negative 4, see these are in 2's now, at negative 4, I would get negative 8. That would be right here, except that that point is not on my graph. That point is missing from my graph. It's a hole in my graph. And you can see it's a hole in your graph rather than a vertical asymptote because it makes negative 4 makes both the numerator and the denominator 0. That one's a tricky one. Now if they didn't give you one quite like that, if they gave you one that didn't cancel top and bottom, then you're going to want to create a t-chart. You're going to want to find your vertical and your horizontal asymptotes, and the vertical have to do with what makes the denominator 0 but not the numerator. The horizontal, you look at the degree of the top and the bottom. It's a little bit more involved, but you make yourself a t-chart there. And if nothing else, since it's multiple choice, just try to eliminate exactly which ones don't make sense at all and then take an educated guess. Okay, now the next 3 terms of this arithmetic sequence. Now you have studied 2 main types of sequences, arithmetic and geometric. Arithmetic means they're getting bigger or smaller by the same amount. You're adding a common difference to go from one term to the next. Geometric, you have a common ratio that you're multiplying by. It might be making the numbers bigger because the ratio might be bigger than 1, or it might be making them smaller. It might be between 0 and 1. Oh, heaven forbid with the negatives, and it's alternating back and forth in sign. But in this case, I can see to go from one term to the next, I'm subtracting 6. To go from one term to the next, I'm subtracting 6. So to get the next 3 terms, I take 21 minus 6, I take 15 minus 6, I take 9 minus 6. And those are the next 3 terms. Now, again, it's multiple choice. So if you go back and look at your multiple choice, make sure that they make sense, that they're common sense. Like if the numbers were, none of them did, if the numbers were getting bigger, then you could eliminate those right away. Now here's another arithmetic sequence, and you don't have to do anything fancy but use a little common sense on this one. Again, it's arithmetic, that's going to help you. You know that it's getting bigger or smaller by the same amount. And look, you go from 4 here in the first term to the 4th term is 19. But you don't have the common difference. But remember, whatever this is, you're adding to here, you're adding to here, you're adding to here to get to 19. Well, the difference between these 2 numbers, 19 minus 4, is 15. So to get in 3 jumps, an increase of 15, you'd have to add 5. You'd have to add 5 each time. 4 plus 5, 9. 9 plus 5, 14. 14 plus 5, there it is, 19. 19 plus 5 is 24. You can just use a little bit of common sense there. You can trial and error it if you needed to. Okay, because it's arithmetic and they're all positive, so nothing's really too tricky. Now it would have been more of a pain if the difference here wouldn't have been divisible by 3. if this had been a 14, because then you would have had to be getting bigger by 2 4/5 each time. That makes it tougher. All right. Well, that finishes up the first 15 problems now. The first 7 on the first video, and then these 8 problems on this one.